Hi everyone. Today we are going to see the case study on battery management system. What is battery management system? In this video, we are going to see about how we are going to motivate about using the battery management systems and what are the safety operations area in battery management systems and main introduction about battery management systems and battery management system key functions and general functions of battery management systems and how the batteries are balancing and performance of battery managements, and finally we are going to conclude about battery management systems. So the main purpose is how the batteries, stored batteries, are going to manage and how it is used, how it is utilized, and how it is given back to the transmission system. Okay, so first point, how motivation. So we all know that batteries are a key. It plays the main roles nowadays. So while the global market for storing power is forecasted to explode, we have, this is the global, today's global market needs battery management. Now, batteries faces issues like safety and causes. The main issues are safety and causes. Okay. Now, the lithium ion batteries are the main usage of battery storage systems, and it causes, and main issues it causes fires on one and smoke on others. And we know that on 98787 jet failed in January. So because of this lithium ion batteries, it goes fired. So one battery got fired and other got smoked. And lithium ion batteries are fragile, and protecting circuit is required to assure safety, and even if they are provided super high capacity. Okay, now we need safety and how the cost, in minimal cost, how we are going to protect. Okay, now we can see what are the types of batteries, and we can see what are the types: alkaline, zinc carbide, and lithium iron chloride, and zinc. These are the batteries. And here the anodes are zinc carbonate, zinc, and lithium, and zinc, and cathodes are magnet dioxides and carbon fluorides and sulfur oxide, oxygen. These are the cathodes, and normal voltages are 1.5 to 3.6. In this we are seeing the 3.6, and approximately the space energy density is this, and its characteristics is this. So here first, the alkaline is lifelong life, shelf life, and supports high to medium drain applications. And we can see here it is low self discharging, can support only 20 years battery, and it is high energy density, but the lifetime is low, within week to month. Okay, so these are the some of the common type and characteristics of battery. Next is safety operating area of lithium ion batteries. What are the safety operating areas? And it depends upon the voltage, current, temperature, and charging discharging areas, and battery ages, and current status of the charges. Here we can see that the temperature, it is lies between, here we can see between the temperature and charging and discharging. This graph shows the graph between temperature and charging discharging. So the temperature lies between, discharging lies between minus 20 degrees Celsius to 60 degrees Celsius, and the charging lies between 0 degree to 40 degrees Celsius. And here comes with the voltage and current graph. The voltage varies from peak minus 5 amps to 20 amps. Sorry, current varies from minus 5 amps to 20 amps, and voltage to 2 volt to 3.6 volts. These are the safety operating area of lithium ion batteries. So above this voltage or below this voltage, if we operate this battery, then we can face this kind of battery heating and battery firing problems. Okay. Next, battery management systems. So main objective is protecting and preventing of the system from damage. So why we are managing the battery is the main thing to prevent the system from damage. Okay. Now next is it increase the battery life. The main next thing is it increase the battery life, and it maintains, or maintenance of the battery system is accurate and reliability state. And BM is also known as battery doctor. We can check, we can protect, we have to protect from any damages. We have to check the management. So like a doctor. Okay. Next is the main key function. So it is a balancing between the communication and balancing safety, electrical, and thermal and energy. So it's a main balance between safety measurement, electrical management, and thermal. So it is a balance. Okay. Here then coming to BMS functionality. So the main function is first power up. The function is main function. The system checkup. The SM power up. So SM system management power up. So second thing is measuring. By you measuring voltage, temperature, measuring current and cell or voltage, temperature, and diagnosis and package of voltage, current, temperatures. These things comes under measurements, and we are gathering the data, gathering the data of voltage, current, temperature, and high in the diagnosis. This is in the normal mode, and we are calculating the state of charges and state of health, heat temperatures, and power limits, balancing, and data variations. Okay, these are comes under calculations. And next one is analysis or judgment. How we are analyzing a judgment is battery status, how it is status, and surrounds of BMS electrical parts, and control. Finally coming to the control, so PRA control, cooling, charging, and can spay control. Then and finally the power down, and data will be saved, and SM power down. Okay, so this is the main battery management function, and this is bilingual is recovery. The next is battery key management functions. The battery management control unit. It consists of first is state of charge displays, that is SOC indication, state of charge indications, and motor control. So SOC informating for regenerative braking and management control. This controls the braking system and management system. And cooling, heating and cooling, on off signals, thermal control, the heating and cooling, thermal control of battery packages, and manual auxiliary charges, that is charging control, battery packages, measurement current, voltage, temperatures of the battery modules, and safety devices, the protection of electrical apparatus. And finally battery status history, diagnosis data, and finally goes to the pair PCs. These are the main battery management system unit. And balancing, this picture shows the balancing. This is the ideal balancing system, balancing state of charge, but this is state of discharge is also uniform, but practically we can see in real world the battery discharging is not uniform. You can see here the battery discharging is not uniform. It differs from each and individual battery. Now unbalanced package, here we can see four cells which is connected, which is discharging, but this is equal balanced discharging. You can see all the batteries are discharging equally, but this is unbalanced. See different discharging of batteries. Here the charging of batteries is a balanced charging, at all are equal. This is the imbalance, unbalanced charging. Okay, now types of balancing. We have passive balancing and active balancing. So passive balancing removes the excess of charges in the form of heat by using the resistor, but active balancing, it delivers the energy at charges. It charges from higher energy cells to deliver into the lower energy cells for the purpose of element as a capacitor used to store the energy. By using the capacitor to store the excess energy, it delivers in the form of heat energy, passive. And finally, coming to the battery management system conclusions, it is an essential element for the batteries to perform surveillance, control, balance, and diagnose in order to just keep the cells so states, but to collect data that have the possibility evaluate how the battery behaves with time. Okay, here we can see the overall block diagram. Here battery management system consists of input of voltage and power supply, current, and we have a power devices. We have a disconnecting device. If something problem happens, it can disconnect, and we have the displays, and we have vehicle control, etc. So we have so many things. Okay, thank you so much. You can see in next video.